Hello guys, welcome back to the video. So today we are going to see problem number 3195. Find the minimum area to cover all the ones. Okay, so it's today's POTD. Let's get started. You are given a 2D binary array grid. Find the rectangle with horizontal and vertical sides with the smallest area such that all the ones in the grid lie inside this rectangle. Return the minimum possible area of the rectangle. Okay, so we have to find a rectangle height and width such that all the ones in the grid are covered. So you can see this example here. If we make a rectangle of 2 by 3, all the ones are covered. And similarly here we only need one because others are 0. So let's take another example here only, like 0 1 0 0 0 0 1 0 1. Okay, so for this, as you can see, right, I've made a matrix. For this we have to cover all, actually a 3 by 3, because one is here to cover this 1 and 1. Okay, so we'll require all. Okay, so how can we find that? Okay, we need a height and width. Okay, and then we need to multiply it. So that's the logic we are going to use. Okay, so let's traverse through it first. Okay, let's traverse to it. Okay, so it will be 0 1 2 0 1 and 2. So what I think is, like, we can take 4 points here, which is the minimum height, the maximum height, the minimum width and maximum width. Okay, min, width. Okay, min height, max height. Okay, and say min width and max width. Okay. Okay. Initially, we will initialize this min width with 1001. Okay, this also 1001. Okay, and maximum height with 0 only. Okay, we'll just read the constant first. So grid dot length, grid dot I dot length is less than equal to 1000. So that's why I've kept the maximum. This can be the maximum value, and the input generated is such that at least one will be there in the grid. Okay, so it's never going to happen that we will return a 0, and grid of ig is either 0 or 1. So they have given all these things. So let's expand this. Okay, okay, so let's take this one first. 0 0 index 0 0. So when we get a 0, anything we have to do? No. Okay, we'll move to the next one, that is 0 and 1. So 0 height and 1 width. Okay, so what we'll do, we'll take this 0. Okay, and we will add it here. Okay, so we'll make this 0, and for the width we will do the same thing here. We'll remove this and we'll make it 1 initially. And what is our maximum height and width? It will be same. Okay, we have only one occurrence of 1 as of now, so it will be 0 only, and here it will be 1. Okay, let's move forward with this iteration. 0 0, we'll skip all these zeros. Okay, we'll come here. So here we our height is 2 and our width is again 0. Okay, so let's update the height variables first. Okay, so for height, the minimum height should be 0 or 2. It should be 2. So we'll keep on adding or replacing it with the minimum part, means it will compare with 0 and 2, and we'll take the minimum, that is 0, and here we'll compare it with maximum. So here it will, for maximum we'll take this. Okay, so we'll slash this one and add 2 here. Okay, similar case we'll do for width also. Okay, so minimum is 1 here, so we'll just remove it because we have got a 0 also. So we'll add 0, and 1 we'll keep 1 because 0 is less than 1. So we want here maximum width. Okay, then we'll iterate again. Then we'll come to this last one where index will be 2 and 2. Okay, so again we'll do the same thing. We'll take this 2 first and try to update the minimum height. Will not update it because 2 is greater. Maximum height already it is 2, so we'll keep it like that only. Then we'll take the width of 2. Okay, then we'll try to update the minimum width. That will not update. And maximum width, yes, we can update it because we got a greater width than its original value. So we have got this. Okay, I'll just erase other things. Okay, and write it now. So we have got 0, this is also 2, this is also 0, this is also 2. Okay, so now we need to find a height and width. Okay, so how we'll get a height, that is maximum height minus minimum height, and we need to add 1 because we are indexing, that is minimum height can be 0 but that is index, so we'll just add 1. Okay, and we need to multiply this with same procedure for width also, maximum width minus minimum width plus 1. So in this way we got the both of the things. Okay, and the answer will be here 2 minus 0 plus 1, 3 into same 3 equal to say 9. So if we covered this 3 by 3 whole grid, then only we are able to cover the all ones. So hope you get the idea clear. Now you can pause this video and try to write the answer, or else you can follow the video and I will write it for you guys. Okay, so let's get started. So we'll take first 4 variable and start min h equal to 1. Okay, max h equal to 0 initially. Then we'll take same for width, min w equal to, and max w equal to 0. Then we'll simply iterate through the grid. Grid dot length for ti equal j equal to 0. J should be less than grid of 0 dot length j plus plus. Okay, and if we get a 1, if grid of ij, sorry if it's not visible, I just zoom in. Okay, if grid of ij is equal to 1, then we will update our variables. Min h equal to math dot min of min h itself and I with the indexes. Max h equal to math max of max h comma I. So for minimum we are doing taking minimum, and for maximum we are taking maximum. Same will repeat for min w. Okay, that is minimum and maximum width. I'm a little lazy in writing, so I'm just copy pasting it. Okay, yeah, this is done. And the formula at the last, return max h minus min h plus 1, because we are using zero based indexing, and similar thing here also, w and w. Okay, hope you get it clear. Let's try to run it and see how it works. Okay, we got one answer is wrong. Let's see. Okay, min w max w, I think we should get it wrong. Let me check. So if you notice here, because of my laziness and copy pasting, I kept here I only. So I need to change it to J. and then let's see how it works. Yeah, it's working fine. Let's try to submit it. Yeah, it worked. So here your time complexity will be, as we are just iterating through the grid, will be m into n. Okay, means row into column. And space complexity will be big of 1 as we are not using any extra space. So hope you guys like this video. So thank you for watching it. Bye.